Hello students, welcome to EDUHUNT online video classes. In this series of lectures, we have discussed the prime factorization method to find the HCF of any numbers. Now we are going to see long division method, which is used to find the HCF of any numbers. Okay, let's see. Long division method. In this method, we use division. Okay, right. Let's see with the example. Find the HCF of 32 and 40. 32 and 40. Here 32, 40. Smaller number is 32, bigger number is 40. That is why we should divide this 40 by 32. 32 once 32, I will get the remainder 8. Now divide this 32 by 8. 32. So 8 4s are 32, remainder is 0. Therefore here 8 is the HCF of both 32 and 40. Okay, right. This is how we are going to calculate the HCF of any two numbers by using long division method. Okay, let's see next example. In the previous question, we have seen two numbers. Now in this question, we are going to see three numbers. First take these two numbers, 252 and 324. Take the smaller number as divisor, 252. We have to divide 324. Two numbers are 3-digit numbers. So 252 ones, 252. Remainder is 2, 7. Again, this 252 should be divided by this 72. 252. Now 72 once 72 not possible. Here it is 25, so it is not possible here. Now take 72 threes, 216. It is 6. It is 3. Now this 72 should be divided by this 36. 72 here. 36 2s 72, remainder is 0. Therefore HCF for these two numbers, that is 252 and 324, is 36. Now take this HCF and the remaining number, that is 594, and do the long division. We will get the HCF of all three numbers. Here it is 36. It should divide 594. 36 once 36. Here remainder is 3, 2, 4. 36 sevens, let's take 42. 7 3 is 21. 21 plus 4, 25. So it is bigger number. So we should not take 36 6. That is 216, because 6 cube is 216. Remainder is 14 minus 6, 8. This is 1. Now divide this 36 by this 18. 36. 18 2s 36. Remainder is 0. Therefore this 18 is the HCF of all these three numbers. Okay, right. Let's see the next example. Verify the following numbers are co-primes or not. Here we should know first what are co-prime numbers. We can take any two numbers. The HCF of those two numbers must be 1, then those numbers are co-prime numbers. Okay, now see, let's take one by one. Co-prime numbers, here one point we have to remember, Co-prime numbers need not be prime numbers. Co-prime numbers need not be prime numbers here. 19 is prime number, but 14 is not a prime number. Even though one number is not a prime number, they can be co-prime numbers if they don't have any common factor other than 1. Here 14 and 19 are not having any common factor other than 1, therefore this pair is co-prime. And this is 39 and 26. This 39 is divisible by 3, 26 is not divisible by 3. And this is divisible by 2, this is not divisible by 2. These are also co-prime numbers. Yes. If I take another one, that is 13 table. In 13 table, 13 2s 26, 13 3s 39. Therefore, these are not co-prime numbers. Okay. And one more point we have to remember here. Any two consecutive numbers are always co-prime numbers. Let's take 5 and 6. These two numbers are not having any common factor other than 1. Therefore, these are co-prime numbers. These are two consecutive numbers. Here 7 and 8 are consecutive numbers. So, these two numbers are also co-prime numbers. Okay. Let's move on to the next one. Find the HCF of 120 and 144 by prime factorization method and division method. First, we should take prime factorization method. How do we find a HCF of any given two numbers by using prime factorization? First, we should do the prime factors of the given numbers. Let's take 120 here. 120 is written in this manner: 2 60s, 2 30s, 2 15s, 3 5s. Okay. And 144 can be written in this manner. In 3 table we can do 144. In 3 table we can do 3 4s 12, 3 8s 24. And again 3 table, 3 1s 3, 3 6 18. 2 table, 2 8 and 2 4s, 2 2s. Okay. 120 can be written 1 2 3, 2 cube into 3 into 5. This 144 can be written 1 2 3 4, 2 power 4 into 3 square. So, HCF of these two numbers is, we should take the least exponent of the common factor. Here 2 is common. 2 is common, but here least exponent is 3. So, we should take 2 power 3. And in this one 3 is common, least exponent is 3. Therefore, 2 cube into 3 is the HCF. 2 cube is 8 and 3. 8 3s 24. 24 is the HCF of these two numbers. Okay. Let's take the division method. So, what is the smallest number here? Smallest number is 120. 120. This 144 should be divided by 120. 120 once 120. Remainder is 424. Now, this 120 should be divided by 24. Here write 120. 24 how much? 24 5s. 5 4s 20 0, 5 2s 10 12. Therefore, 24 is the HCF of these two given numbers. Okay. Even though whatever the method we follow, we get the same value. Okay. Let's see the next one. Find the HCF of 18, 24 and 16 by prime factorization method and division method. Let's see. First, prime factorization method. Take the prime factors of 18. 3 6 18, 3 2s. and 24. 3 8s, 2 4s, 2 2s, and 16. 2 8s, 2 4s, 2 2s. Okay. Now this 18 can be written 3 square into 2. This 24 can be written 3 into 2 cube. This 16 can be written 2 power 4. Now, what is the common factor here? Right. Here 3, 3, no 3 is there. So, we should not take 3 as a common factor. And let's take 2. 2, 2 cube, 2 power 4. In this one, 2 is the common factor. But in the HCF, we should take the least power of the common factor. What is the least power of the common factor? Here 2. Therefore, HCF of these three numbers is 2. Now, find the HCF by using long division method. Let's take these two numbers first. 18 should divide 24. 18 once 18, remainder is 6. Now this 6 should divide this 18. 6 3s 18. So here 0. So here 18 and 24. HCF of 18 and 24 is 6. Now let's take this 6 and 16. This 6 should divide 16. 6 2s 12. Remainder is 4. This 4 should divide this 6. 4 1s 4. Remainder is 2. Now this 2 should divide this 4. 2 2s 4. Remainder is 0. Therefore, here 2 is the HCF of all these three numbers. Okay. In prime factorization method and in long division method, we got the same answer. Okay. That is 2. Okay.